Are you in class? Are you in now?
Good afternoon, Doc.
Good afternoon.
Good afternoon, Doc.
Good afternoon, Doc.
Are you all in?
Good afternoon po, Doc.
Not yet, Doc.
Kulang po, Doc.
Not yet, Doc. 76 pa lang po.
We'll start now or no? There are still coming in. Mag-start na tayo?
Sige po, Doc.
Okay. So, biomedical importance, we have the extracellular matrix has three major classes of biomolecules. You have your structural proteins, example, your collagen, elastin, fibrin. Then specialized proteins such as fibronectin and laminin. And proteoglycans. Okay? So these are the three major classes. Now we will deal more on, this afternoon we're going to talk about this one because it is the most important, collagen. Huh? Okay. So there you are. Collagen is the most important and most abundant protein in the animal world. Almost all tissues contain collagen. And there are about 28 types of collagen and made from 30 distinct polypeptides. Now, each of these polypeptides is being encoded in a gene. Okay, so each of these polypeptides has its own gene. Okay. At this point, some of you may not have a picture of genetics, but we will take this up. Now, to start with, we have about 1 million genes. And out of that 1 million genes, there are only around 10% of the 1 million genes that are used for coding the proteins that make up the whole body. And our collagen comprises 20% of the total protein. Okay? Right. So there are 28 types of collagen. And we said most tissues contain collagen. So collagen is very, very important now. All right. Types of collagens. There are 28 of them. So we have listed there 9. Then we have 13, or 18, I'm sorry. And then we have 28. Okay, let's start. Let's go back. So type 1, they are found in non-cartilaginous connective tissue, including bones, tendon, and skin. Very important, skin. Then type 2, we have cartilages, vitreous humor. What do you find is vitreous humor?
Eyes, Doc.
Your eyes. Okay. Type 3, there you are again, skin, lungs, vascular system. Why? Because these are the extensible connective tissue, meaning it expands or it dilates and relaxes. No? Okay, and can contract. So that's vascular system. Then 4, basement membranes. 5, minor component in tissues containing collagen 1, and that is non-cartilaginous connective tissue, bones, tendon, and skin. So these tissues not only contain type 1 but also contain type 5. Muscle and most connective tissues, and that is type 6. Dermal and epidermal junction. So it is in the skin again. No? It's again the skin. Dermal and epidermal junction. So it is in between your dermis and epidermis. Then type 8, endothelium and other tissues. And type 9, tissues containing collagen type 2. And these are your cartilages and vitreous humor. Okay. Type 10, hypertrophic cartilage. So cartilaginous again. Type 11, those containing collagen 2. So you go to the type 2. And this one, tissues containing collagen 1 for 12. And for 13, many tissues, including neuromuscular junction and skin again, here. Neuromuscular junctions. Okay. And then type 14, containing collagen 1, tissues containing collagen 1. Type 15, collagens close to the basement membrane in many tissues, including eye, muscles, and your micro vessels, very, very small blood vessels. And type 16, many tissues. Type 17, epithelial tissue, no? And the skin. Type 18, collagens close to the basement membrane and structural homologue of 15. So very similar. These two, no? 15 and 18. All right. 19 is rare, not common. So found in basement membranes and rhabdomyosarcoma cells. 20, many tissues, and particularly cornea. 21, many tissues again, 22, tissue junctions, including cartilage, synovial fluid, hair follicles, and dermis. Then 23, limited in tissues, mainly transmembrane. 24, developing cornea and bones. 25, brain. 26, testes and ovary. So in reproduction, is also very important. And 27, embryonic cartilage and other developing tissues. And cartilage in adults. Basement membrane around the swan cells. Okay. For type 28. Okay. Now, showing these types, we just only to tell you that collagen is plentiful. And as I've said earlier, almost all tissues has collagen. So if there is something wrong with the synthesis of the collagen, then you will have a large number of disorders. Okay? All right, so let's go into the structure. Collagens have a triple helix structure. What do you mean by helix? You have seen that already, no? And that is your secondary structure of protein. Remember, you have the alpha helix, and the other one is the beta plated sheath. Diba? Okay, so it is a triple helix. So meaning to say, three strands are, all right, three polypeptide chain or subunits, no? Alpha chains, and then it is wound into a helix. So mature collagen type 1 belongs to this type. Three of these polypeptide chain form a right-handed triple helix or superhelix. And glycine here is the most abundant amino acid in collagen, which occurs every third position of the triple helix is a collagen. Okay. Now we know that collagen is the smallest. Uy, nasulti ko na. Part of your exam, I said the smallest amino acid. Lagi, bonus na lang. And it is the only amino acid small enough to be accommodated in the limited space because you are going to form a helix. So every bend of the helix, you find a glycine. So much so that you have a repeating sequence of amino acid. You have glycine XY. Okay, so amino acid glycine followed by 2 XY. This X and this Y could be any amino acids. Okay, X and Y could be any amino acid. But most of the time, X is proline and Y is hydroxylated proline. So I'm not saying that this could not be occupied by another amino acid. As I said, most. X is proline and Y is hydroxylated proline or hydroxyproline. Okay? So you say X and Y can be other amino acids. The X are often proline and the Y is hydroxyproline. Okay. Proline and hydroxyproline confer rigidity. So that makes it rigid. Okay. Hydroxyproline is formed by post-translational modification of the proline. What do you mean by post-translational? You see, when a messenger RNA is being translated by the ribosome, then you have a chain of amino acids. Now, any amino acid there can be modified or may be some molecules or a group of atoms could be attached to it. So that is what is meant by post-translational modification. So it is modified by adding some group of atoms. Now in this case, the proline is hydroxylated, post-translational hydroxylation. Okay, so it says here, post-translational hydroxylation of a peptide bound, meaning to say it's already in a polypeptide chain, proline residues, catalyzed by an enzyme, prolyl for proline hydroxylase. So these are enzymes that adds a hydroxyl group. And the cofactor is very, very important. This is where your ascorbic acid comes in. And alpha ketoglutarate. Alpha ketoglutarate is the carbon skeleton of glutamic acid. What do you mean by the carbon skeleton? It is the organic acid of your glutamic acid or glutamate. So that's alpha ketoglutarate. So what is removed from glutamic acid is just the amino group, and you have now the carbon skeleton known as alpha ketoglutarate. Okay? So again, back to this. You have glycine. This can be occupied, X and Y, by any other amino acid. But most of the time, X is being placed here in this position. And that is proline. No? And Y, the proline that is hydroxylated. However, another amino acid may come in, lysine. And lysine occupies the Y position. And just like proline, your lysine can be translationally modified. Post-transitional modification again of lysine to form hydroxylysine, hydroxylated lysine. And this is due to the action of your lysyl hydroxylase, which uses cofactors, vitamin C again, uses vitamin C as cofactor and alpha ketoglutarate. Okay? So, the most prominent abundant amino acid in a collagen is glycine. Next would be proline and then lysine. And of course, proline and lysine are modified so they become hydroxyproline and hydroxylysine. All right. Now going back to this hydroxylation, the OH, what is the use of that OH? What do you think is the use of those OH there? Why does it have to be plentiful of OH? Now remember that it forms a triple helix. So there must be something that will not unwind the triple helix. And what is that? Hydrogen bond from which amino acid? All right, your hydroxylated proline and hydroxylated lysine. So that is the importance of vitamin C there. What is the disorder when you lack vitamin C for a long, long time?
Scurvy.
Scurvy. Now, scurvy is not common now. But there are, what do I call this? I should clarify that statement that it is not common. There is still scurvy, but the scurvy is localized. Meaning to say, you have ascorbic acid, but it is not enough. Like for example, even if you are using a toothbrush which has very, very soft bristles, and every time you brush your teeth, your gums bleed, that is a sign of low vitamin C. Now remember, collagen is found in almost all tissues. And that's your gum there. And you know that wound healing becomes retarded when vitamin C is deficient. So you can see now the importance of your vitamin C. Huh? And then what about your eyes? Is there collagen in your eyes? Yes, of course. So, again, it is not only your collagen-bearing tissues that you can see right away, and that is your skin, because that is already in frank scurvy. The skin is very, very fragile. Just holding tight to an arm, and then you slide it off, the whole skin slaps off in frank scurvy. You can see now, but that does not happen anymore. No, that does not happen anymore because there is vitamin C. Not only supplemental vitamin C, but you can get it from your diet. Fresh vegetables, it's very, very important. Now, this used to be a scourge among seafarers long, long time ago, time of Magellan. You are, of course, familiar with the history of Magellan. How many months, how many years it took them to reach the Philippines? A very long time, di ba? And they do not have, what is their source of food? Well, they have grains, of course.
Coconut.
That is if they go island hopping.
Fishes.
If they go island hopping. Where does coconut grow? Tropical countries. You do not have coconut in Spain or Portugal. Diba? Now, the main source of vitamin C is citrus. And also, green leafy vegetables. Correct? We do not
Liver,
have
Doc.
refrigeration at that time. They do not have refrigeration at that time. So their diet consists of grains or cereals. And of course, their source of protein is salted meat. Salted or dried meat. That's the source. Or if they fish, because they are already in the water, they can have fish. But no vitamin C. That's the scourge of the sailors before. The lack of vitamin C. Okay. So you expect that those people or those the sailors before are prone to vitamin C deficiency. Now this was corrected by a famous explorer also, one of the explorers that reached America. And when they landed in that part, which is now called Florida, 3/4 of the sailors have scurvy. And the American Indians at that time took pity on them, and they were nursed back to health by giving them a decoction of pine bark of pine trees, which is rich in vitamin C. That's decoction, meaning just boiling. And they were nursed back to health. And so, I don't know, I forgot the name of that famous explorer. He's an English explorer. So, when I went back to England, he brought along this pine bark. And the researchers in England identified it as vitamin C. And so, from that time on, sailors, when they embark on a voyage, they bring with them a sack of lemons, because lemon can be preserved for quite a long time. So they bring with them a sack of lemon, each one of them. And that's why they were called limis. I don't know if you understand that. So when they call them limis, they are English sailors. So my limi, there's a song about that, no? The limis. Okay. So there you are. So the importance of vitamin C, because the enzyme prolyl hydroxylase and lysyl hydroxylase cannot operate or cannot work in the absence of vitamin C. Okay? And also this one, I have to emphasize this also. It says there that collagen is plentiful in the blood vessel, vascular system, the blood vessels, the tubes itself, especially the one that is elastic. Oh, that even includes the lungs. So, if vitamin C is deficient, then the collagen of the blood vessels is weak. It's weakened. And you know that the blood vessels are subjected to stress, because the heart pumps the blood, and that stress is propagated until the minute arteries or the arterioles. So much so that if it is weakened, then it might, if it occurs in very small arteries, then you have hemorrhages there. Small hemorrhage, very, very small. But if it occurs in blood vessel that is big, then hemorrhage is uncontrollable. And it roughens the intima of the blood vessel. A rough intima is the beginning of atherosclerosis or atherosclerotic plaque. Because if there is any roughening of the intima, when the platelets passes through that rough area, it will burst. And when a platelet bursts, that is the beginning of a clotting mechanism. And we cannot afford blood clots inside your blood vessel. But then, roughened blood vessels tend to repair itself. And there are extracellular matrix proteins that brings about the repair. It brings about the repair. And it uses oxidized LDL, which you commonly call bad cholesterol. No? You commonly call it bad cholesterol. Actually, LDL is the bad carrier because cholesterol is neither good nor bad. Cholesterol is needed. But it just so happened that the LDL is the one that carries that cholesterol that is being used to smoothen rough intimal surface of the blood vessel. And when an atherosclerotic plaque is observed, and if the patient dies, they do autopsy and they look at the atherosclerotic plaque and try to find out what is the composition, and they find cholesterol, and they say, Eureka, it is cholesterol. So the bad name now of cholesterol is there. But it is just a rider on the LDL. The opposite of LDL is HDL, di ba? And you call it the good cholesterol. Actually, HDL is the good carrier. The cholesterol is just there. Just so happen. No? Innocent bystander. And it is being made the culprit. It's a very long story about that. And I remember in the 1950s, 1960s, there was a cholesterol scare. Because when they do autopsy on the atherosclerotic plaque, they will be able to find cholesterol. Naturally, because that cholesterol there was being used to pave, to make the intima of the blood vessel smooth again. You can see? So, what does the FDA say in the United States? Minimize cholesterol rich foods or fatty, oily, greasy food. Now, when the Americans follow that, they still have atherosclerosis. So therefore, it is not the cholesterol. They are minimizing cholesterol, and yet atherosclerosis is still there. And now, they said it is not fatty, oily, greasy food. And you know what is being blamed? It is sugar. Now, it's sugar. That's another story. We'll talk about it when we take up metabolism of carbohydrates. Okay, let's continue. We have been missed. Okay, so there you are. You see this glycine XY, glycine XY, glycine XY. And you know what those XY are. No? And then it forms a helix. That's the alpha chain. Okay? And then three of these alpha chain forms a triple helix. There you are. And has a diameter of 1.4 nanometer triple helix. There you are. And then it forms a fibril. Okay, that fibril there. Triple helix molecule, 300 nanometers long. That's the fibrin. Okay. The N here means the amino N and the carboxyl N. No? So you see that. So in order that these three will not unwind, hydrogen bonding. Now, if there's no hydrogen bonding, this is lost. And the collagen is weak. Can you see that now? Huh? Okay. All right, it says here, some collagen types form long rod-like fibers. Some are short fibrils, no? From 10 to 300 nanometers. Okay, all right. And the fibers from 1 to 20 microns in diameter. So there is, aside from cross-linkings with hydrogen bond, you have also covalent cross-links brought about by ang oxidizing enzyme, lysyl oxidase. What we had before is lysyl hydroxylase. This is oxidase, a copper-dependent enzyme that deaminates the epsilon amino group, I'm sorry. The epsilon amino group. The epsilon amino groups of lysine and hydroxylysine. To form reactive aldehydes and then forms aldol condensation with lysine and hydroxylysine residues of the alpha subunits. Okay. Now, aside from that, histidine may also be involved in the cross-linking. It says the main fibril forming collagens in the bone and cartilages belongs to type 1 and type 2 collagens. Okay, so they are numerous, type 1 and type 2, in bones and cartilages. Some collagen types do not form fibrils, meaning long triple helix. Some are very, very short. So we have these types. We have the fibrin forming 1, 2, 3, 5, 11, 14, 27. It forms long fibers. This one forms networks. Now this one facets These are fibrin-associated collagen with interrupted triple helix. And then we have filaments with beads, beaded filaments. And then for anchoring purposes, we have type 7. And transmembrane collagen, we have 13, 17, 27, 23, and 25. And multiplexins, 15 and 28 and 18. According to the structures they form. Okay. Now this is the one that we mentioned. Collagen undergoes extensive post-translational modification, hydroxylation of proline and lysine. Now after that, there is another modification decorated with glucose, glycosylation of hydroxylysine modification. So aside from hydroxylation, we have glycosylation. Okay. So order and location of processing the fibrillar collagen precursor. You have two types, those that occurs inside the cell and those outside the cell. Okay. So what is done inside? Cleavage of the signal peptide, hydroxylation of prolyl, as well as lysyl residues and glycosylation, formation of intra and interchain disulfide bonds. What particular amino acid can perform this? Cysteine, sulfur containing, the thiol group, SH group, and formation of triple helix. So this occurs intracellular. Extracellular, these are the processes. In order to process what we call mature collagen. So collagen are secreted from the Golgi apparatus. So we have enzymes which acts on pro-collagen, meaning not the mature or not the adult type of collagen. So amino proteinase and carboxy proteinase. So these are enzymes which acts on cleavage of the peptide bond. Now, amino proteinase starts from the amino end of your polypeptide, and carboxypeptidase from the carboxyl end. Okay. Once the collagen are matured, they spontaneously assemble into collagen fibers and then stabilized by inter and intra-chain. Inter within the chain, within the polypeptide, and intra-chain between polypeptides through the action of lysyl oxidase. We mentioned that kanina, di ba? Okay. So the same cells that secrete collagen also secrete another extracellular molecules, molecules, yeah. Fibronectin, a large glycoprotein, which is present on cell surfaces. Fibronectin binds collagen fibers. Together with that, proteoglycans like heparin sulfate and chondroitin sulfate associate with fibronectin and your raw collagen. After these linkages, your collagen becomes metabolically stable. Now, excessive productions of collagen occur also in a number of conditions, such as liver cirrhosis. What is the most common type of liver cirrhosis that we have here in the Philippines? And this is your alcoholic cirrhosis. You try to pickle your liver, by taking in alcohol. Okay? So that your liver, once it is autopsied, there are a lot of fibers. Okay. Collagen fibers. That's hepatic cirrhosis or liver cirrhosis. So we have here a number of genetic and deficiency diseases results from abnormalities in the synthesis of collagen. Now, we remember that we have 28 types of collagen coming from 30 types of subunits or polypeptide chain. And each polypeptide chain comes from a single gene. Okay? So, if there is something wrong with the gene, naturally you come up with a defective subunit. And that subunit, you know that 3 of those subunits, alpha subunits, are used to make a triple helix. Okay? And the deficiency here is through the inability to hydroxylate your proline and your lysine. So, genetic from the genes, deficiency from vitamin C. It's no problem with the alpha ketoglutarate as another cofactor because there's always plenty of alpha ketoglutarate. What is not present is vitamin C, because vitamin C cannot be formed by our body. Alpha ketoglutarate can easily be formed. Now, you can just imagine this, that there are 8 enzyme catalyzed post-translational steps. 8 enzyme catalyzed post-translational steps in order to form a collagen. So it is not, therefore, surprising that you will have diseases as a result of a defect of the enzymes. So it could be due to mutations in the collagen genes, or the genes for that collagen, and the genes encoding the enzyme. Example is osteogenesis imperfecta, if affecting the bones. So that would be type 1 collagen. Oh? Okay. All right, we have here enzyme affected. Ehlers is collagen 1A1. No? So that is osteogenesis imperfecta, osteoporosis, Ehlers-Danlos syndrome. Then you have collagen 2AA1, severe chondrodysplasia, osteoarthritis. Collagen 3A1, Ehlers syndrome, Ehlers-Danlos syndrome. Subtype vascular, blood vessels are involved. And so you have that, no? And so here you are, or the disease, the gene for the collagen, or the gene for the enzyme. And we have here lysyl hydroxylase. We have here lysyl oxidase, or Menkes disease. Lysyl hydroxylase Ehlers Danlos syndrome. Now, anyway, now this is not easily seen. I have only seen once this type, osteogenesis imperfecta. Only once. I have not seen it anymore. Now, this Menkes disease is mostly the absence of copper. You have a good enzyme, no mutation of the enzyme, and yet copper is lacking, because this is copper dependent. We have Menkes disease. Ehlers-Danlos syndrome is called cutis hyperelastica. So from that name alone, you know what it means. The skin is very elastic. So We have here hyperextensibility of the skin, increased joint mobility, and tissue fragility. So you can see that, no? Ehlers Danlos syndrome or cutis hyperelastica, hyperimmobility. So we have here classification of Ehlers Danlos syndrome. Again, this is not seen well in tropical countries where part of our diet are fresh vegetables, green leafy vegetables, which gives us vitamin C. But this is common in cold countries. And so what do they have there? Clinical signs, joint abnormality. And this is, if it is vascular type, organs easily break, blood vessels easily break. And you can see this thin and translucent skin, prone to bruising. And there is that on the bones, especially the spinal column, curvature of the spine, scoliosis, severe muscle weakness, and then hyperextensibility again, and easily bruised skin. Now, this one is very fragile and sagging skin. So you can see this incidence 1 is to 10,000, 1 is to in 20,000, 1 in 100,000, 60 cases up to this, 40 cases only, 10 cases only. So even these are not common. This one are rare. 60 cases worldwide, 40 cases worldwide, 10 cases only worldwide. Okay? Now this one affects the kidney, Alport syndrome. This is X-linked autosomal. Type 4 collagen are affected. This is the basement membrane of the kidney. Renal glomeruli, the inner ear, and the eye. So if there is something wrong with that, then you will have the kidneys malfunctioning, inner ear, and the eye. Signs and symptoms: blood in the urine, hearing loss, and eye lesions. And then end-stage renal disease. So they do not live long. Epidermolysis bullosa, skin breaks and blisters occur as a result of minor trauma. Mutations of your collagen 7A1, which affect type 7 collagen. This collagen acts as fibrils that anchor basal lamina to collagen fibrils in the dermis, so the skin. That's why you will have breaks in the skin and blisters occur. So there is marked reduction of type 7 collagen. Scurvy. So scurvy is dietary deficiency, not a genetic abnormality. Bleeding gums, subcutaneous hemorrhages, or wound healing. Signs of defect synthesis of collagen due to reduced activity of hydroxylases for proline and lysine. Menkes disease is also copper deficiency. Lysyl oxidase is dependent on this enzyme, on this mineral. This enzyme is dependent on the mineral copper. Now, by the way, I was asked the case studies, cholera, scleroderma pigmentosum, muscular dystrophy, osteoporosis, and Alzheimer's disease. These are supposed to be case presentation to be made by students. Now, it is very hard for students to do this, so we will just reserve this towards the end of the year, hoping that we can have what we call face-to-face lectures, not virtual lectures. So we can divide the class into groups and they will present the case in any way. But anyway, all of these cases are in your book. They are there. All you have to do is just look at it, and then the case is well discussed, and then you can refer back to the lecture for that. Now here's another interesting protein, elastin, a connective tissue protein that is responsible for extensibility and elastic recoil. So what organ can you think of? Most important is your lungs. Di ba? Most important is your lungs. All right. Out, of course, your blood vessels and your ligaments. So again, this elastin, the disorder here is not also common. Not common. Unless, of course, you engage in something, in some lifestyle that it destroys particular tissue that produce elastin. No? Like, for example, your lungs. Very common, you try to smoke out your lungs. Now that lung disease, because of smoking, could be prevented. Because you cannot find any reason why you should smoke your lungs. For what reason? Well, I have to confess that I was also a smoker until I was able to assist in the post-mortem examination. And the lung, the person died barely 12 hours before we had the post-mortem procedures. And when we opened the surgeon opened the lung cavity, I saw that the lungs is black, gray black color. I asked my surgeon, did he die of smoke inhalation? Then he said, oh yes, of course, he died of smoke inhalation. But a chronic smoke inhalation. I said, what do you mean, smoking? He said, yes. And I was smoking at that time, and I was already consuming almost 1.5 packs every day. And so when I saw that lung, very black, grayish black, and the surgeon made an incision on the lower lobe, and the surface of the incision were cut bronchial vessels, and comes out, oozing out from it is a black tarry liquid. I asked him, what is that? So that is tar. So he asked me if I'm smoking. I said, yes, better stop it. So right after that, I went upstairs in the hospital. I opened my locker and I still have 6 rims of cigarettes. I took it out and I gave it to my co-interns who were playing cards because they are previous 24 hours. So I asked, who wants cigarettes? And they were all surprised because they know me that I am a smoker. How come you are becoming a Santa Claus, when Christmas is so long? I said, I will stop smoking now. And they did not believe me. So, but I stopped right then and there from that experience. I have seen a smoker's lung. Okay, let's go back to this. So the elastin here is very, very important for recoil, no? Elastic recoil of the tissue. Okay. Okay, this is still elastin. All right, so we have here differences between collagen and elastin. Okay, elastin has only one genetic type in comparison to collagen, which has many different genetic types. We have 28 types of collagen, and we remember that there are 30 genes, no, which produce different alpha subunit. Now, collagen has a triple helix, elastin no helix, but random coil. So you can just see a random coil which permits stretching and recoiling back, just like a spring. And then the sequence of the 3 amino glycine XY is not seen in elastin. Collagen has hydroxylysine, there is none in elastin. In collagen, carbohydrate can be added, but no carbohydrate in elastin. Cross-linking aldehydes and seen in collagen, but there is dysmosine cross-linking in elastin. Then in collagen, you have presence of extension peptides during the synthesis, but there is none in elastin. So that's the difference. The big difference there is, of course, triple helix, the glycine XY. All right. Deletion of the elastin gene as seen in animals. No? Things about pulmonary emphysema, cutis laxa, and aging of the skin. Because there is no more elasticity. So emphysema. And they call it Williams-Urine syndrome. Now, the microfibrils, collagen, microfibrils. We have another type of protein, fibrillins, is a glycoprotein. It's the major structural component of fibers. Okay. I have not seen any of this disorder. It's very uncommon, very uncommon. This one, Marfan syndrome, there's mutations of the gene for fibrillin. Again, this is very rare disorder, which affects the eyes, the bones, cardiovascular system, transforming growth factor. So we have here acromicric dysplasia and galeophysic dysplasia. Short in stature, very thick skin, and very stiff joints. Probably you have not seen this kind of patient. Short stature, skin thickening, and very stiff joints. Marfan syndrome. Fibronectin is very important now here, is in cell adhesion and migration. It's a glycoprotein. It has two identical subunits joined by a disulfide bridge near the carboxy terminal. So this is for cell adhesion and binding to receptor which contains arginine, glycine, aspartic acid sequence. binds to the integrin receptor. Okay. Mind this. You cannot see this in your lifetime. Also this one. Laminin. This is the protein that holds together laminin. The microscopic structure of this laminin is like a cross. It's like a cross in which Jesus Christ was nailed to. And this holds everything, the tissues, laminin. So quite an important protein. Now, this is the laminin here. It's a cross. This one. But we seldom find disorders of this. But if there is, it usually affects the kidneys. Now you have your proteoglycans and glycosaminoglycans. Disorders, again, are not common. So this is just only for biochemists. These are your, for the protein, these are the carbohydrates that are attached, usually glucose, acetylated glucose, sugar acids, glucuronic acid here. Then you have, aside from glucose, you have galactose, and sometimes xylose. Where is xylose? Here we have xylose. And hydronic acid. Hydronic acid, here we are. Hydronic acid. This is glucuronic acid, N-acetylated glucogalactose, and glucose. N-acetylated glucose, N-acetylated galactose. So this is a table for your glycosaminoglycans, sugars that are involved, linkages, and where they are located. So there are the sugars. Glucosamine is hydronic acid, glucosamine, hydronic acid, glucosamine, glucuronic acid, and acetylated glucose. So just the function of these glycosaminoglycans and proteoglycans. So these are the functions, structural components of your extracellular matrix, have specific interactions with collagen, elastin, fibronectin, laminin, and other proteins such as growth factors. These glycosaminoglycans and proteoglycans, they're more or less stable, and there's not so much of a problem with them. So they are polyanions, bind polycations and cations, contribute to characteristic turgor of the various tissues, acts as filters, and facilitates migration of cells. There's a role in corneal transparency, structural role in the sclera, acts as anticoagulant, neuroheparin, components of plasma membranes may act as receptors, determine selectiveness of renal glomerulus, components of synaptic vesicles, and other functions. Okay. Errors of degradation of these glycosaminoglycans brings about what you call mucopolysaccharidosis. So inborn errors of metabolism produces mucopolysaccharidosis or MPS. Oh, here are your mucopolysaccharidosis. Signs and symptoms, and those that are affected. Glycosaminoglycan affected. Enzyme deficiency are all of this. Now, these are well documented, but unfortunately there are not so many cases of mucopolysaccharidosis. Now, only usual genetic disorders that may occur is what you call this, intermarriages within the family. No? Because if the two of you, husband and wife, have both recessive genes, it becomes dominant. And this is unlikely to happen, very rare cases in the Philippines. We do not marry into our own family. But in other countries, intermarriages in the family is common. That's what they have there. But we do not have that in the Philippines. And usually genetic disorders. Never mind this. Okay, proteoglycans. Hyaluronic acid is very important in permitting tumor cells to migrate. Okay? Tumor cells can induce fibroblasts to increase the amount of glycosaminoglycans, thereby facilitating their own spread or metastasis. Some tumor cells have less heparan sulfate at their surfaces, and this may play a role in lack of adhesiveness that these cells show. In the arterial wall, especially in the intima, okay, contains hyaluronic acid and chondroitin sulfate, dermatan sulfate, and heparan sulfate. These proteoglycans, dermatan sulfate, binds to plasma LDL. Plasma LDL. Although this is what we call a mechanism in which the intima of the blood vessels try to repair the rough surface inside the intima, it brings about atherosclerotic lesions. It employs low density LDL, which carries cholesterol. So they utilize the cholesterol, oxidize the cholesterol. They use it as a paving agent. It paves. No? Just like your street, when it has potholes, you are going to lay asphalt on it, not to make it smooth again. So that is what the intima is doing. Try to smoothen a rough surface inside the intima. And so, it repairs by utilizing LDL. And LDL is smooth, yes, but it is also sticky. Cholesterol is smooth, but is also sticky. And so, form elements of the blood as it passes through that area, some form elements stick to the intimal surface, and thereby making it rough again. So another layer of LDL cholesterol is used. So the plaque increases, and the lumen of the blood vessel becomes smaller and smaller. And so when it is small, you need a high pressure for the blood to pass through. And so one of the signs would be hypertension in atherosclerosis. Okay. Also, arthritis. They also act as autoantigens. My God, autoantigens. And there are autoantigens, then immune bodies acts. Right? And so you develop osteoarthritis. So your immune bodies is now acting on the tissue. So this is autoimmune disease. Okay. All right, so these are proteins found in your collagen. In your bones, you have principally your collagens and the non-collagen proteins. So you have plasma protein, everything there. Okay. Bone resorption, osteoclast, osteoblast, respectively. Osteocytes are found in mature bones. So bone disorders, either metabolic or genetic. And if it is genetic disease, then there's not do anything about it. But if it is due to some deficiency or metabolic disorders, deficiency of materials for the bones, like calcium, phosphates, the collagen. So we have all here dwarfism, growth hormone, rickets, vitamin D in childhood, osteomalacia, vitamin D in adults. Now, what's so important about vitamin D that brings about rickets and osteomalacia?
Calcium absorption.
Calcium absorption. Without this one, vitamin D3. Now, this is not much of a problem here in the Philippines because the sun is all year round. Unless, of course, you do not go under the sun. Now, 10 to 15 minutes exposure to the sun, not the early morning sun, it's the noon sun. Makes it about 10 to 12. Intense. Okay, so that gives you 10 to 15 minutes. About 30% of your body is exposed to sunlight. It's enough to have that vitamin D3. And then your thyroid hormone, very important. Calcium, phosphates, the protein collagen that comprises your hydroxyapatite. Osteogenesis imperfecta, brittle bones. You have 8 types of this. Very, very brittle bones. The sclera is also affected, very thin and translucent, and appears blue because of deficiency of the connective tissue. 8 types, 1 to 8. So type 1 is mild, type 2 is severe. Okay. Osteoporosis. And this one is the opposite. Osteopetrosis, where you have increased bone density. While in osteoporosis, bone density is reduced. Increased bone density, inability for in the resorption of bones. And absence of carbonic anhydrase 2, mutation of the gene for this enzyme. So the osteoclast cannot resorb normal bone. And increased density of the bones occur. Osteoporosis, the density of the bone is diminished. It leads to skeletal weakness. Occurs in women after menopause due to lack of estrogen, which promotes bone resorption, and decreases bone mineralization. And you see the bone is remodeled. So there is nothing old in you. You say you are 23 years old or 24 years old. Your bones is not 24 years old. Or any tissue for that matter is not 24 years old. Because of this constant remodeling. Bone is resorbed and then it is new bone hydroxyapatite in place. So there is always remodeling. It all depends on how long will a remodeling last. There are those that remodeling is very, very fast, or replacement is very, very fast. Cells are destroyed and cells are replaced. Also with bones, it's also like that. Your skin, you replace your skin very, very easily. Every day when you are going to take a bath and scrub your skin, a lot of dead cells are removed. And this has to be replaced. Your hair is always growing. Even you die, when you die, the hair still grows for a few days or a month. There is constant degradation and replacement. Major components of cartilage are type 2 collagen and certain proteoglycans. Type 2. Proteins found in cartilage. Type 2. Then you have 5, 6, 9, 10, and 11. Type 2 is about 98%, and this is only about 2 to 10%. And others, so what is important? This one. So chondronectin for your cartilage, attachment of type 2 collagen to chondrocytes. Chondrocytes, the cells in your cartilage. Cartilage is non-vascular. So if you break your cartilage, it will take a long, long time to heal because there are no blood vessels. See? It gets its nutrients from synovial fluid. A very slow turnover. Responsible for degradation are your proteases. These proteases are your collagenases and your stromilysin. So if there is something wrong with the gene that encodes your type 2 collagen, then you will have problems with your cartilages. And you have what we call Stickler syndrome. Stickler syndrome. Degeneration of the joint cartilages. And the eye. Remember, that's type 2. So dwarfism with short limbs, achondroplasia, short limbs. The gene encoding fibroblast growth factor is the one that is important here. The gene, fibroblast growth factors. Other mutations. Okay. So again, short limb dwarfism. You have phenotypes. This is acanthosis nigricans, brown to black hyperpigmentation of the skin. Okay. Tomorrow we will review. Hello. You still there?
Yes,
Yes.
Doc.
Yes, Doc.
Are we
Yes,
good?
Doc.
Yes, Doc.
Thank you.
Yes, Doc.
So,
Thank you po.
Thank
the
you, Doc.
chapters that we have lectured on, then will be the ones that will come out in your first bi-monthly. Now, I just want you to look at the most important part. And you can get that by looking at your objectives for each chapter and the summary. Huh? Anyway, we will be talking about it tomorrow. So we'll have a review. You can just have a recording or you can just write down. Okay? So it's only
Doc.
most important thing in this chapter
Thank you,
is your
Doc.
collagen.
Thank you, Doc.
Your collagen, the most
Thank you,
important
Doc.
thing.